everyone, welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week our theme is intermittent problems, those disruptions where things look fine one minute but not the next. We'll be discussing intermittent issues for Meta and Salesforce users, as well as a maintenance-related automation bug that affected Google Cloud. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Thousand Eyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to like and subscribe. And for all our YouTube listeners, don't forget that we also release this show on all the major podcast platforms, so feel free to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. On with the show, and I started by asking Mike to explain what happened at Meta.
So on May the 14th, there was about 3.5 hour disruption for some users of Meta services. Now, these included Facebook, Instagram, and some WhatsApp. What we actually saw was that the web servers themselves sort of remained reachable. So you could actually get network connectivity to them. You could actually get to the service, which would indicate to be some sort of back-end service or issue. This was actually likely the cause there.
One of the indications that this was an intermittent problem was the cancellation effect you saw when monitoring the disruption in Thousand Eyes. Explain what you mean by the cancellation effect, Mike.
When we actually see an outage, what we start to see is this sort of pattern evolving. You can actually see pictorial what's occurring, and it likes to leave footprints or breadcrumbs of essentially what's occurring there. So what we talk about when I'm talking about a cancellation effect is if I'm actually looking at the number of servers impacted. So this was the servers that were exhibiting outage conditions or error conditions or disruption conditions in this case. Now, what we saw there was we looked at the number of servers impacted. So it was going from, like, say, 2 up to 4, then back down to 2, then maybe up to 7. And it created this cancellation effect, like the sort of the edge of a castle where you sort of sit and fire your arrows through there. Now, the fact that we saw these numbers going up and down, as we talked about in the past, we start to see this increase. We're talking about a load. So we're seeing it sort of impact more and more servers. But the fact then we were going up and down kind of indicates that some of these servers were recovering, or they were reachable during this period of time, or they were able to respond to a request. So that's what we mean by obviously this cancellation effect. So if we actually look then what that actually means, we have this situation essentially where we have an intermittent fault, which is sort of a service may appear to be working and not working simultaneously. Schrodinger's outage, if you will. So we sort of have this outage occurring. Is it alive or is it dead at the same time? But the fact then, like I say, we saw these servers recovering in terms of numbers gives us an indication that we're actually getting to the servers. So what it actually then manifests itself to was some sort of slow performance. Because we have this recovery, it means what you do is the degraded performance, it's slow as opposed to a complete outage in the back end. It will just manifest itself as slow response.
Another sign of intermittent problems was timeouts interspersed with HTTP 500 errors. Explain what the 500 errors indicate.
So it wasn't so much these signals in isolation, but actually taking them together. So we had a number of things occurring here. So we had the HTTP 500s. I'll explain what they mean to me in a minute. And then we had sort of these timeouts where the system was just timing out. It just actually was making a request and the page would actually time out. So just too long to respond, basically. Now, I take all these together, and when I'm looking at a 500 error, we've talked in the past about this concept of the status codes. They are status codes. They're telling us the status of a system. When we see a 5XX, so there's a number of sort of different errors or status codes that can be associated to that, what it indicates to us is a server-side issue. So that means the server is responding, coming back. Now, we quite often see a 502, which is a bad gateway, a 503, service unavailable. And what in this case we saw was a 500 itself. So we're actually talking about a specific status code coming back as 500. And what that is, it's a bit of a catch-all error code, as you'd expect, sort of 500. It means an internal server error. What that means is it received something, it couldn't understand the syntax, or wasn't able to respond to the request coming in. Basically, it replies on that end server. Now, where that differs from looking at a 502 and a 503 is they are effectively coming back from the proxy. So they're saying, I made a call and I couldn't actually respond to it. So I've got a bad gateway, I've got some network connectivity issue, I can't reach it, or a service unavailable, I've made a call to a service and it's actually not responding at all. Whereas a 500 is more indicative it's coming from that end system. So we've got no sort of back-end network connectivity issue as such. We just happen to be able to reach this server and it can't process it at that time. Now, combine that together with all the other signals, so the timeouts and the fact these 500s were coming and going, again, sort of indicates this intermittent side, and put that all together with the servers recovering and not, and it looks like that the server was unable to respond for some reason.
Intermittent errors are something of a theme this week. and they affected some Salesforce customers on May the 16th. Here's Mike to explain what happened.
What manifested itself here was, it was actually sort of a DNS level. So if we think about the foundational steps of when we're making a connection, the first thing we do is we'll actually look up that name and turn it into an IP address so we can communicate to the service itself. Now, what was happening in this, and I'll explain why they're intermittent again, was we started to observe, or there was observed some DNS failures. So these occurred when you're trying to make that connection. And again, they were failing on some of the DNS servers as well. So it's resolving some of the names there. So this is why we're talking about some services, but also the way that DNS is set up means there's multiple systems and there's different records, and we sort of put them down there. So there's different ways to actually look it up and sort of get that address there. So if I'm actually going through that process and make the connection once it's started, then it just, if it times out, then I might go to the next one, or I'll actually resolve around that way. So it was actually timing out that foundational step, but it wasn't completely failing. So it was actually just timing out, then we're going to another one. This is then we had that intermittent impact. So how it would work was then if I actually went to go onto my Salesforce instance, I'd actually make my connection, type in whatever page I'm going to, and then it would actually, it'd take a long while, or it'd time out. I just simply hit it again. Next time it might go in. So from a user point of view, yes, it's disruptive and it's actually slow making that connection. But once I'm in there and starting doing my records, unless I'm actually trying to go to a sub page or another system within there, I'm effectively not doing a new lookup. I'm relying on my cache. I'm trying to get in that information anyway.
Why would a problem with one third-party DNS provider cause such issues? Aren't DNS lookups spread across multiple servers to avoid these problems?
We don't know specifically what occurred in this instance, but there's various different things that happen with the DNS. And if you think about it, even from a security point of view, so DNSSEC, we're actually starting to go through and verify the record or verify the resolve we're sending the information to. So we're going through this signing process. If there's some sort of problem within that, some configuration, and again, it's quite common to actually use sort of third parties to actually do this. Exactly the reason you said, because I want to spread it around. I want to spread my DNS service around, so I'm actually maintain that connectivity and maintain that ability to look things up. But if I actually start that process and I say there's some sort of degradation in there, some sort of configuration error, or even something wrong with the validation, and again, I've started the process, everything looks like it's working well, but I have this delay while it's going through. And the way, for example, the reason I chose that is if I'm actually coming down and looking at that DNSSEC process, there's various sort of fallback mechanisms that actually take place as it goes through to the validation. So obviously each process there, if there's an issue in that or an issue in the signing, then we're going to have this degradation occur and we're going to just add time on. And remember, even if we're talking in a magnitude of milliseconds, if I start to do those round trips up and delay, it adds up quite quickly. We've talked about in the past this impatient user. If I'm sitting there, if I don't get a response very quickly, it's the same here. I just get there and my system times out because I need to be able to get that response come back quickly.
How can service providers ensure they're not impacted by these kind of problems?
So let's take this back to a wider audience. Let's think of if I were dealing this from any enterprise perspective that's running my own DNS service or using a third-party DNS service. Obviously, I've architected at that point, but then it comes back to really being able to understand everything together. We talked about in the Meta disruption, where we're talking about the combination of signals. This is everything coming through. I said, if I actually think about the process I do when I make a connection, there's so many steps that go on to do this, to making sure I can resolve the right name, but also I'm actually going to go to a service that's local to me. So I don't want to have to travel halfway around the world. So all of these things have to take in place and they're all seamless to us. They all go under the covers. And each one of these, in theory, is going to be monitored by some individual tool set, or, we're looking at the syslog files from a server to understand the errors loading. All those individual lines might be green and I can see everything's actually up and working. It's only when I put everything together to understand how they interact together. And this slight variation or degradation in one area might have a dramatic roll-on effect somewhere else. But unless you actually view that in context, you're not going to see. Now, as I said, these interruptions or these whatever malfunctions will occur. That's a fact of life. These things are going to happen. What you need to do is to be able to understand where it is so you can react quickly. And this is more the point, to understand where it is and even sort of proactively. If I'm looking at this process, I'm going, hang on, that seems to be taking a long time. So, taking this right out of this particular problem, looking at another one, I'm starting to see certs have an issue, right? So my certificate expires, I actually then can't connectivity. If I can identify that cert's about to expire by looking at my traffic, therefore I can take proactive action and make sure I reissue a new cert beforehand. So I'm saying that's not related to this one, but we're talking about those types of things that can occur. But if I'm just looking at it in isolation, I might miss it and then we get that break in service delivery.
Google Cloud customers may have suffered some disruption on May the 16th. Here's Mike to explain what occurred.
So on May 16th, Google Cloud experienced what turned out to be a global network connectivity issue. There was a number of their services impacted, around 32 services that were impacted, but it had this flow-on impact where it directly impacted a number of SaaS, sort of web-based companies where they were having some of their systems or services they were running on Google Cloud unreachable, basically. So it manifested for their customers where they actually couldn't operate front order systems or various parts of ordering systems within their platform itself.
Can you tell us a bit more about some of the other companies that were impacted by this problem?
So Shopify experienced sort of error messages. And as I said, the way this manifested, it was actually a back-end network problem where you actually then couldn't reach the services. So there was packet loss, and Shopify had this outage for about sort of 1 hour, 45 minutes. As I said, they actually couldn't reach back-end systems that were running within Google Cloud. So it disrupted the ability to sort of order stuff on Shopify and actually sort of transact in that area there. GitLab also faced some issues. Again, they had some Google Cloud hosted nodes. And in this case, they sort of saw these 503 errors, which they began to actually look at and sort of troubleshoot down this. But then they were able to attribute those to sort of Google Cloud Platform. So remember, we talk about a 500 error. A 503 is a service unavailable. And in this case, it tells us again, okay, so we have a back-end networking problem because we actually can't reach it. That service is unavailable. I actually can't get to it. So I get to the front door and then I try to make the connection to the back-end service, which was running on something connected by this network device there. And I actually couldn't get to it. So hence the users got responded with a 503 error. And then Cockroach DB users were sort of impacted again for about 80 minutes. And then this was, again, this networking issue. So they couldn't get to their back-end systems. You could get to the front end, but when you try to interact with the back-end, they actually couldn't get there and service disruption occurred.
Services such as Shopify are of course used by other third-party websites. So it just moves the problems further and further down the chain, doesn't it?
Yeah, absolutely. Absolutely. And that's actually a really good example. You know, we have these dependencies upon dependencies. You could even go as far as sort of logistics companies sending stuff out are all going to have this flow-on effect right down. So this is when we talk about not omni-channel as such, but that service delivery chain. It's including everything. And I need to look at it from my perspective. It's all right saying, oh, okay, Shopify is up to them to look at their performance coming back in and they can do that. But they don't necessarily have the relationships that you have or the responsibility, more accurately, the responsibility for that end-to-end service delivery. So this is why it's important to actually take everything in together because you can have these real sort of flow-on effects and knock-on effects, as you say.
This appears to be a case of an automated maintenance process intended to be deployed in one location, accidentally propagating across multiple locations. So instead of shutting down a single instance, a network device was shut down across multiple instances, creating the knock-on problems that Mike described earlier. So what are the lessons to be learned here for NetOps teams?
Understand what you need to automate and also have these checks in place. Not everything needs to be automated. There's sort of processes in there. I talked about this concept of doing the routine tasks, the tasks where I need to sort of crunch lots of numbers. I need to go through the things where human error, as it were, sort of can play a major role. You know, I might miss a dot off. I think I might have told you this, and I apologize if I said this in the past. I once had an issue where as I pressed the return key on a router configuration, I shut down a system in Russia. I was in Germany at the time. There was no way of actually getting to it. I kind of bricked the system, and the only way you could get there was to actually go and send an engineer over there to sort of power cycle the thing to sort of getting it back up. So the point of that is these mistakes happen. Automation does a really good job of sort of taking care of those tasks there. But also you have to be aware that bugs can be introduced because we're running on scripts. What you need to be able to do is to have some sort of fail-safe in there as well. Even if you think about it from like a DevOps perspective. So when I'm rolling out code, we work living in an agile world. I'll make changes to various small bits of code around there, and then I'll add my branch into the overall system, and it goes on. That can have a flow-on effect within the rest of the system. So I need at some point to actually look at that holistically. I need to look at everything across the same time. So once you've looked at the automation process we have in place, at the same time, I need to be sort of checking it all the time. It's not necessarily a lights off operation. And that can actually even be done by another system. So I can have a system checking a system, but the point is have these things in place, and then overarching everything, I need to know how is the overall service impacted? Because again, you know, even if you think about this particular incident, if I take out one active network component, that's how it was designed to do. But then the fact is the problem that take that one out, then took another one out, then took another one out in isolation. Yeah, it's not too bad. Obviously, I'm going to impact these services that are connecting through there. But in theory, I've just taken out this network layer. And again, think about the sort of the size of the Google environment. But if I'd had some way of going, okay, what we've done, we haven't shut that one down, we haven't brought another one back online, someone's actually checking that or another system checking that, then we have that fail-safe in place.
Before we wrap up the show, let's turn to the overall outage trends. What have we seen over the past fortnight, Mike?
So global outages increased by 5% from May 6th to 12th and by 43% from May 13th to 19th. So that's the total global outages we actually observed there. This was mirrored in the United States, where they experienced a 22% increase in outages from May the 6th to the 12th and a 27% increase from May 13th to the 19th. Now, interestingly about this is then we actually look at how many US-centric outages contributed to those total global outages. And if you remember, we've been seeing, apart from the last period, we've sort of seen them going over 40%. So this time it was 39%. Last time it was 34%. So this is the second time this year where we've had two consecutive 2-week periods where we've actually dropped under that 40% of US-centric outages.
So, after a dip at the end of April and the very beginning of May, we're now seeing outages increase once more. Any thoughts on why that's happening? And will this upward trend continue for the rest of May and June?
So typically I'll start to see this increasing. So again, if we go year over year, I start to see this increase coming in. So this particular rise we saw, and we saw a significant rise here, 43%, when we talk about the number of total global outages. I can actually attribute a lot of those to some maintenance work. So this occurred outside of the US in sort of a different region, in the APJC region, the Asia Pacific region, and that then accounted for a vast number of those outages. Now, when we actually see that, obviously there are outages. Some of them were destructive in terms of they started to have some performance impact, but that's why we then saw that decrease. Now, why I'm talking about that is because what I'll start to see now coming up into June, I'll start to see an increase in maintenance work. So we'll start to see sort of people upgrading systems, putting stuff in there, and this starts to raise the number of outages we see. So not all of them destructive. Some of them will be announced in a scheduled maintenance, and then you'll see that. And in others, we'll see where it doesn't have any impact whatsoever, but we'll just pick it up as an outage, but they've managed to sort of route around it or take mitigating action before it takes place.
And that's our show. Please like and subscribe. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on X at @thousandeyes, or send questions or feedback to internetreport@thousandeyes.com. Until next time, goodbye.